kilogram falls 9.0 meters from a storage building and lands on a trampoline. The person stops after traveling 0.2 meters down from the time she hits the trampoline. Determine the spring constant of the trampoline. So we'll start with a picture. Here's the building. Here's a trampoline. The person's going to fall 9.8 meters. And then there will be another 0.2 meters of the trampoline falling. So here's the person, and they jump. We'll say they land like that. So initially, I don't have any kinetic because I'm resting at the top of a building, and I do have gravitational potential. And I don't have any elastic because the trampoline has not been stretched yet. In the end, I don't have any kinetic because the question says the person is stopped, so there's no kinetic. There's no gravitational because they've fallen as far as they can fall. And I do have elastic though, and thermal's not mentioned, friction's not mentioned, and if friction's not mentioned, don't bring it up. So all of my energy at the end is elastic. And so I am going to say that in my system, I've got the person, I've got the trampoline, and because I'm falling vertically and it makes problems easier, I'm going to include the Earth in my system. And so my quantitative equation ends up being gravitational potential is fully converted to elastic potential. So gravitational potential is mgh, and elastic potential is 1/2 kx squared. And I'm just going to rewrite the variables up here so that you can see how I plug in numbers. Oops, forgot the k. Alright, so my mass is 60 kilograms. Because I'm on the surface of the Earth, I'm going to use 10 for g. If I were somewhere else like the Moon or Jupiter, I would use a different value. I'm falling 9.8 meters. K is what I'm looking for. And the spring is depressed 0.2 meters. Now you may wonder, why aren't I including that as negative gravitational potential energy on the final situation? And the reason why is because I'm not building up or I'm not losing any gravitational potential energy when I fall. All of the energy, or fall that additional 0.2 meters, all of that 0.2 meters is going into the elastic energy account. There's nothing going into the gravitational potential energy account, because if I just had a piece of board there, for example, instead of a trampoline, I wouldn't be building up any additional gravitational potential energy. The only reason I'm building it up is because I'm building up any energy is because all of the energy is going into my elasticity account. So on the left side, I've got 5,880 joules, and so we can fill this in and put 5,880. And on the right side, I've got 1/2 k times 0.2 meters squared. I know that that is also equal to 5,880. It's because of the way the math works. And so I'm going to solve for k, and so k is equal to 5,880 times 2 divided by 0.2 squared, and that gives me a k of 294,000 newtons per meter.